Go ahead.
So, okay, great. Hi everyone. Welcome. Thanks for attending this recruitment event. My name is Jun Li. I'm currently a assistant professor in the um, Paul M. Randy Department of Mechanical Engineering at CU Boulder. So I'm also new. I've went through an application process, and there are reasons I choose mechanical engineering and also biomedical engineering program here. I'm also glad to share you guys with these reasons. So today, I'm going to give you an overview of biomedical research in the department. Want to know the exciting research happen here? Okay, let's begin. So as I mentioned before, as you are going through this process, I also went through a process to, that's the reason I'm here. So I believe there are compelling reasons to select CU Boulder and biomedical engineering here. First, CU Boulder is a Tier 1 R1 university with a very high research activity, and is one of the America's leading research universities. Our College of Engineering and Applied Science ranked top 10 among the public peers, as well as top 20 among all the national universities. So biomedical engineering program is under the mechanical engineering department, one of the big um, one of the big six departments in the college. Okay, so there are strong reasons we should choose these biomedical engineering programs. First, um, our faculty members here are all nationally renowned. They are leaders in their fields, and their research involves diverse fields. Secondly, in this program, so you will have a chance to collaborate with an array of institutes. As Vera mentioned before, we can collaborate with Anshu's campus, and you will also have the chance to collaborate with BioFrontier Institute. Is an institute funded by Nobel laureate Thomas Cech on the campus. And you can participate in this IQ biology program. It's a program to foster collaboration between PhD students. As we mentioned before, you have the chance to collaborate with hospitals, medical campus in or near the Boulder region. And once you join this program, you will have access to the top-rated research facilities. So for example, like the advanced light microscopy core and light microscopy core here, we have a lot of different microscopes like fluorescent microscopes to photon microscopes, and you name it. You will also have access to the COSINC, which is the Colorado shared instrumentation in nanofabrication and characterizations. You can use these instrumentations to fabricate high precision bioelectronics. So with all these aspects, you can participate in cutting edge research, pushing the frontiers, the frontier boundaries. So in this department, what kind of research we do in these programs? So let's talk about it. So all faculty here, their research focuses on engineering, health, and life. Specifically, there are five major topics, and there could be even more, just the five major ones. Namely, there are biomechanics, biomaterials, biofluids, and biomedical engineering and the biomedical devices. There are also several faculty members working on the soft robotics, medical robotics. So let's walk through all these areas. Sorry, I have two screens here, so sometimes maybe like one screen get delayed. I'm trying to keep the two screen all simultaneous. So in biomechanics, it is one of the big major areas our faculty focus on. There are 8 faculty members whose research involved in this field. So in biomechanics, we are doing studying the mechanics of extracellular matrix, and we are studying cancer mechanics and the soft tissues and hydrogels. There are even some core projects related to space. For example, we have faculty members send the mice to the space and then study the bone, tissue, and organs change during the stay in the space. So the second one is biomaterials. We have 6 faculty members working in this area. So in biomaterials, our research focuses on natural biomaterials, bio-inspired materials, biomimetical materials, as well as some materials we can use for devices. Here are 2 examples. First, the left one is the tattoo. Our faculty members working on implantable tattoos and use tattoo to monitor your health care, your body health. And we also have faculty members working on develop biocompatible, degradable, reliable materials to make implants, like vascular implants, work longer inside our bodies. So the third field is biofluids. So we have 4 faculty members working in this field, such as Professor Borden, Professor Botanist, Professor Marie, and Professor New. So they are heavily focusing on using to improve the imaging technologies, such as ultrasound imaging, to improve the quality as well as the precision by using materials such as bubbles to enhance the contrast. You can get a very clear imaging pictures by using this kind of ultrasound and coupled with biomaterials. So the fourth field is biomedical devices. We have also have many faculty members involved in this field. So inside this field, our faculty members are fabricating like biomedical devices, for example, like the medical robots, surgery robots, as well as doing some core research on lab on a chip. They are developing some acoustic surface acoustic equipment. So you can use this surface acoustic equipment to align, to assemble the biomaterials for specific applications. So this is the last field. So after that, I'm going to walk through briefly about what each faculty members are doing in these programs. So maybe we are not going to incorporate all the faculty members. So if you are interested in their research, I will encourage you to review the website as well as contact them by looking at their contact information and their lab website. So first is the Professor Ahmed. So Professor Ahmed's research focuses on understanding how brain controls movement from neurons to algorithms to behaviors. So they are trying to figure out what makes movement so difficult and unraveling the computational process the brain uses to solve these problems. So specifically, her expertise focuses on biomechanics, neurons, and some computational models. So the second professor is Professor Bartlett. So Professor Bartlett's research combines theoretical mechanics, numerical modelings, optimizations, as well as experimental mechanics 3D printings to create, explore, and validate new classes of materials. So his research includes material designs based on precise microarchitectures, as well as some naturally inspired materials, such as the fish films inspired morphine materials. So, and then is Professor Borden. Professor Borden's research focuses on microbubbles, some microbubbles, nano droplets, and other soft colloidal suspensions for use in biomedical imaging and therapy. So he developed medical technologies based on these colloids, trying to aid in the diagnosis and the treatment of disease such as acute respiratory distress syndromes and many other diseases. So his lab have alumni who are working in both in academia and industries, as well as some alumni are participating in startups. So the next professor is Professor Botanist. Professor Botanist's research focuses on improving ultrasound image quality in challenging imaging environment using advanced beamforming techniques. His research focuses a lot in ultrasound, how to improve ultrasound imaging and how to record these ultrasonic motions. So as you can see in the slides, their mission is to bring the value of ultrasound imaging to more patients in more situations with greater clarity and utility than ever before. And then we will have Professor Broom's research combines chemistry, material science, mechanical, electrical, and biomedical engineering. His research is quite multiple disciplinary, and he is also a kind of a science star in the community. So he develops full like wearable devices such as using tattoos to monitor our body conditions. Electronic tattoos is the famous one of his research, and his research also include many other fields. So feel free to look at his website and read more. And then is Professor Covey. Professor Covey's research develops tools to quantify how the composition, turnover, and organization and the mechanical properties of the musculoskeletal system change during tissue assembly. So Professor Covey's research used tools to elucidate how different extracellular matrix, many of her research involved extracellular matrix. So how these extracellular matrix components integrate to form functional tissues during the development, regeneration, and the scar-free repairs. So the mission of her lab is to characterize the material properties of assembly tissues to establish design parameters for regenerative therapies. And then we will have Professor Ding. Professor Ding's research combines micro, nano engineering, biology, medicine, and physics, cutting-edge micro, nano systems, and technologies for various cell-based biomedical applications in life science, healthcare, and medicine. So he used surface acoustic waves to manipulate cells and then to build some drug delivery systems to develop lab-on-a-chip system and then other biomedical microsystems for cell-based applications. The next one is Professor Lynch. Professor Lynch's research identified normal, mechanically sensitive therapeutic targets for treating and preventing bone metastasis, as well as cancer-associated reductions in bone strength. So they will use a lot of in vivo and in vitro mechanical loading model systems to create cellular functions with the cancer pathogenesis, tissue level changes in tumor burdens, and the skeletal tissue strength. Professor Mukherjee's research investigate complex flow physics and transport phenomena. So they seek to unravel how flow physics influence phenomena involving living systems. So like our brain, our like heart, they all have this kind of blood flow. So they investigate how this kind of hemodynamics affect the body conditions and the behaviors. They're also interested in computational mechanical approaches for flow physics, particles, and also particle-laden flows. And we will have Professor Rentschler. Professor Rentschler's research focuses on intelligent medical devices and surgical robots who are setting a foundation for patient-specific medical care and ultimately loading toward the operating rooms of the future. So Professor Rentschler also involves a lot of entrepreneur. So he currently is a founder of a company, a startup company. He's the CEO of Aspero. So they are trying to leading a dynamic team. He's leading a dynamic team through this FDA approval and the initial sales launch. So as you can tell, he's not only a researcher, but he's also an entrepreneur. So similarly, Professor Sergio's research focuses on creating artificial limbs. He also actively involved in entrepreneurship. So he's a founder of multiple companies. For example, he's a founder, a CTO of a company that already acquired by Strike in 2017. So if you work together with professors whose research also have some involve some startups, then you have a lot of opportunities to know about the industry and about the entrepreneurship. So the next one is Professor Tan. Professor Tan's interdisciplinary research is positioned at the cross-section of nanomaterials and the material mechanics with vascular medicine. So they develop biomaterials, in particular micro nano biomaterials, and leverage the biomaterial technologies to innovate medical devices and the 3D biomanufacturing process. So one research project she currently working on is the vascular implant materials, how to develop biomaterials, making vascular implant more reliable, biocompatible, and biosafe. And then it's Professor Verneri. Professor Verneri's research focuses on theoretical, computational, and applied mechanics of intelligent biological and bio-inspired matter. They are developing new models that will guide the development of smart polymers and hydrogels for tissue engineering. So they study the mechanics of disease and they study also the mechanics of soft robotics. So as you can tell, his research also combines computation, theoretical, as well as experiments. And then we will have research of Professor, sorry, one screen. The research of Professor Wacker. Professor Wacker's research combines expertise in biomechanics, haptics, and robotics in order to develop assistive devices that are more effectively interface with complex human and control systems. So they are developing assistive devices that can help with those with movement impairments to or augment everyday movements to reduce fatigue and injuries. So as you can tell, her research focuses on biomechanics, haptical device design, and also biomimetic device control and the feedback. And then is Professor Xu. Professor Xu's lab is an interdisciplinary research group at the intersection of robotics, fluid dynamics, and biology. So their goal is to design and implement swimming robots in real-world environments for applications such as ocean conservation and observing natural phenomena. So one of her research is very interesting is to study how the jellyfish move and then using what we learned from jellyfish move to design soft robotics that can better work under the ocean. So the last is me. So now it's me. So our research integrates functional biomaterial design, advanced manufacturing, and the biomedical application at a multi-scale, aiming for tackling ground challenges in healthcare and sustainability. So our research goal is to develop material innovation platforms such as the 2D and the 3D printing systems for the deliberate design and discovery of biomaterials with exceptional optical and electrical properties. Eventually, we will fabricate biomimetic, battery-free, intelligent devices for personalized healthcare applications. Currently, I have 3 topics of research currently we're working on. So if you are interested, feel free to apply. So that's all the research our faculty currently have. And then in addition to research, we also have a lot of exciting learning opportunities. So you will have many learning opportunities here. The program offers courses that are covering most topics in biomedical engineering. So for example, here I just provide a sample list of the courses that you can find in these biomedical engineering programs. So as I said, you will have many exciting learning opportunities. So at last, I will also want to talk something outside the research. So we have a very strong research here, our faculty members are national leaders here. But outside of research, there are also some compelling reasons you are encouraged to choose the biomedical engineering program. So at CU Boulder, you will have a lot of chance to involve in entrepreneurship if you are interested. So, for example, our university ranked the #1 for launching startups based on the university discoveries. So we are the #1 last year among all the national universities. So there are a lot of industry opportunities near the Boulder region. So you will have opportunities to work for big biomedical companies such as Medtronic and Pfizer. For me, there's another reason. So this region is really beautiful. So here are two pictures took by me and my friend. One is a holistic view of the Boulder region. As you can tell, we are located in the bottom of the mountain regions. So the yellow arrow indicate where we are. So you will have a lot of opportunities to explore the national parks. There are so many national parks nearby. In the meanwhile, now it's fall, so we have a lot of beautiful leaves here. The aspens looks really, really good. I just had a hiking last week, so this is the picture took by my friend. So as you can tell, the leaves are really beautiful here. So at the last, I don't know if after we introduce so much, if you are really interested to apply. So if you want to join us, why don't you be bolder and apply? Thank you. Thank you for attending. I'm happy to answer any questions.